Nice to meet you, Conrad.
Thank you for having me here.
Welcome. So thanks for joining me. I was wondering if you wanted to say a few words about yourself and your publication, Humanity Redefined.
Okay, uh, so professionally, I am a software engineer. I used to code for 15 years, mostly websites and web apps. Somewhere along the line, I created Humanity Redefined, and that first began as a way for me to sharing the links to articles and videos about interesting things around AI, robotics, and biotech that I have found. And over the time, it started to grow and transformed into this publication that is right now, which my aim is to provide good analysis on what's going on at the bleeding edge of technology, what's going on at the fringes of AI, robotics, biotech, all those technologies that can make us more than human or promise to make us more than human, and how they can impact us, and how can they bring the positive future, not the dystopian cyberpunk future, but the positive future in which humanity flourishes. And that's the goal, and that's my mission at Humanity Redefined.
And you have an interesting background because you have a software engineering background, and then you have kind of transitioned over to bioengineering. I wonder why you made that decision.
So it wasn't a, so that transition took some time. I don't remember when exactly this seed of bioengineering got implanted in my mind. I think it was somewhere around 2015, 2017, somewhere around that time, when I started to be interested in vertical farming, those automated vertical farming that don't use any soil and produce the food indoors. I think that was the first uh, sparkle of that idea to move me into bioengineering. And then I can't find any like a singular moment that told me, hey, go do that. I think it was like multiple different inputs and inspirations from all over the place, from the sci-fi that I read and enjoy, from video games that I play, from being immersed in the technology and learning about synthetic biology, learning about bio-inspired systems, learning about bio-inspired manufacturing, and even bio-inspiring architecture. And eventually, all those small pushes, somewhere at the end of pandemic, uh, I got the realization that, hey, it's about time to do something with my life, do something useful that has a positive impact, rather than writing yet another web app that I don't care about. So I started to take the idea of bioengineering and becoming a bioengineer seriously. So at the moment, I am preparing to take exams, like A-level equivalent exams, and to enroll at university alongside educating myself about bioengineering, synthetic biology, genetic engineering, and being more involved in that space.
It's a very interesting combination of skills. I recently read a book by Mustafa Suleiman, who is a co-founder of Inflection AI and DeepMind, and he says that in this coming wave, that AI and synthetic biology is going to be the leading kind of technologies. So you have a pretty good understanding of both with AI from your software background and also from synthetic biology with your bioengineering background. Where do you think what can you say, the mixture between AI and synthetic biology, where's it going to lead here in the short-term future? Maybe the next, let's say, 2 to 5 years. Where do you think things are heading?
That's a good question. So first, at the moment, the big push is in drug discovery. So you have companies like in silico medicine, Isomorphic Labs, which is the spin-off of DeepMind, which are using AI to discover new drugs. So I'm more familiar with how in silico does it. They have a couple of systems. The first system thieves through medical journals and tries to find potential candidates for treating certain disease, like let's say some kind of rare cancer, something like that. So it goes through all the papers that have been published in the last, 5-10 years, and tries to find potential candidates. Those candidates then are synthesized in inside the computer using AlphaFold. So AlphaFold tries to predict what kind of protein will match the given characteristics. I think they also do some virtual tests of that potential molecule. And then when they have a good enough candidate or a selection of good enough candidates, then they synthesize them in real life and start to do proper clinical tests. The big promise here is that this entire process from beginning to end can take, I think, about a month, which using traditional methods where a scientist needs to manually try to find the right candidate for trial and error by synthesizing the protein or that drug by trial and error, that can take years and millions of dollars. So the big promise of this kind of approach in short term is reducing the time and cost in discovering drug candidates. When it comes to long term, well, now we can go into speculation. Like we can have new psychedelics. That's something that I recently read. Some researchers used AlphaFold to find some new psychedelics. The primary focus was to find new antidepressants. But who knows? You can also use them to have new new drugs to get high, like new LSD, like AI LSD. You can create that with this kind of tools. Down the line, those technologies can be also used to find the drugs that can reverse aging. That's something that's starting to emerge a bit more and starting to get into public consciousness, that this whole idea of reversing aging or increasing the health span and therefore increasing the lifespan, human lifespan, is starting to slowly creep into public consciousness. But behind the scenes, millions upon millions of dollars already being invested into that field with some prominent people like Jeff Bezos. And I think that, Jeff Bezos is one of the bigger names that I last year helped to co-found and helped to invest into one of those anti-aging labs. I would be interested to see how this technology can be used in biomanufacturing. Because drug discovery, everything around medicine, that's the low-hanging fruit. That's where the money is, and that's where you can have immediate return of the investment. I would like to see how this technology can be applied outside medical applications. So biomanufacturing comes into mind, like food production. There's an entire industry that tries to create synthetic meat, fake meat, or lab-grown meat. So could be interested to see how this technology can be applied into that field. Could be also used to create cruelty-free food, like lab-grown milk. That's something that I don't remember the name of the company, but I think one company in Israel is already doing that. There are bioengineering bacteria that can produce milk. We can look at lab-grown eggs or any kind of produce that right now we need to have an animal to produce, and that animal is usually either killed to get that food or is treated very badly. Could be also using material to create cruelty-free leather. And beyond that is the limit is your imagination. Like we could start thinking not about manufacturing things, but we can start thinking about growing things. So imagine, that's a far-fetched idea, but imagine a furniture that you don't manufacture, you don't cut the tree, you don't turn that tree into planks, and you assemble the planks to create a desk or create a table. But you grow that table, or we grow roads, or we grow buildings.
Okay, that's interesting. I've never heard about that before.
Yeah, that's something that goes way in the future, and that's something that inspired me. One of the many things that inspired me to go into bioengineering. This whole idea of not manufacturing things, but growing things. You just say, okay, I would like to have this output. Like I would like to have a chair that has this and this parameters, characteristics. And then you leave nature to do it for you. Like you plant a plant, some kind of bush, tree, whatever, and it shapes into a chair. That may not be a feasible example, but I hope it gives an idea what we can do beyond that.
That's another thing I have been thinking about recently. I saw there was a research team at the University of Sydney, and they have made this device called D-Wave, which was actually able to translate people's brain waves into words on a screen. So basically, by wearing a kind of helmet, these researchers or the device they have made could actually translate the participants' thoughts. I think the accuracy was around 40%, so it was not that high, but the researchers believe in the future that it would have around 90% accuracy. And it had me thinking it's also similar to what Elon Musk is trying to do with Neuralink, these mind-reading devices. And in some sense, at least to me, it makes a lot of sense. Like imagine all the time we spend on screens in our lives right now. Imagine if we could replace all of that time and then let our mind make many of these actions for us. So if I wanted to book a table for a restaurant dinner, then I could activate a device by my mind, and then it could send the booking. Or if I wanted to send a text to a friend, I could just think about it, and then the device could write these words and text my friends. Do you think this is something we will experience in our lifetime, or if not, when?
It all depends, because those devices that you described, brain-computer interfaces, are already here. There are people on this planet that have a chip in the brain that allows them to communicate with the world. However, all those devices at the moment are medical devices. Those are not only medical, they're experimental. They're designed to help people that for one reason or another cannot communicate with the world. They could be paralyzed due to accidents, and suddenly they can't speak. They can't move their hands. They can't speak, but otherwise they're perfectly fine. They still react if you talk to them, like they can still understand people talking to them, but they can't speak. They're in this locked-in state. And this technology exists right now that can help them communicate again with the world. It is also being used to bypass damaged nerves. Again, if you're paralyzed, but only from sternum down, you can still move your hands, but you can't move your legs. It is possible to bypass the damaged nerves, and then with the help of with an exoskeleton, brain-powered, brain-controlled exoskeleton, they can regain some level of mobility. So I don't see those devices going beyond medical field for at least 10 years.
Okay.
Beyond that, if we are thinking about going beyond medical applications, the question is, what would be the incentive? Because there's a different question to get a new iPhone, because you just get a new iPhone, right? But the conversation is different if that new iPhone needs to be put into your brain, that you have to undergo an invasive surgery to put a foreign object into your brain and hope that your immune system would not treat it and would not start attacking that device. That's why, going back to synthetic biology and thinking about growing things, recently I started to thinking about how can we create this kind of devices, those brain-computer devices, such like Neuralink is promising to do, that would combine human brains with the power of AI, that are not injected through a robot, a needle-like robot that injects like millions of electrodes into our brains. But instead, it is a device that you ingest with a pill, and then you have some kind of proteins, nanobots, something like that, that finds a way into your brain and starts to build that network in your brain organically. So it becomes like a new organ on top of your brain, and it grows with you. All you have to do is to maintain the right diet, for example, to give enough nutrition for that new organ to properly function. But other than that, it's fully biological, fully compatible with our biological bodies.
So if I understand you correctly, it's kind of like an extra brain?
Yes. And instead of being made with metal or biocompatible electrodes, that are just growing with you. And
But
I think,
what kind of abilities would it give us?
well, we can speculate. So brain-computer interfaces promises to unlock a new way to control and interface with machines. It's just like the example that you said. You don't need to grab your phone, or you don't need to open WhatsApp or whatever app you're using to talk with your friends. You just think about talking to your friend, and boom, message goes directly into their brains. That's the most obvious example. We can also think about having an AI assistant in your head. So you think about a question and boom, you have the answer. You just got the answer in your mind. But thinking beyond that, there might be more interesting applications to experience another person. Because if both of us would have this kind of devices into our heads, it could be possible for me to show you how the world looks like from my perspective, and vice versa. Give better understanding what other people are experiencing, the feelings that they're experiencing, the thoughts that go through their heads, and experience that just as you would be them. Like you'll be literally inside their heads and experiencing that the same thing that they're experiencing. That could be an interesting application that could enhance relationship between humans and promote and maybe build better understanding and empathy between humans. But people are creative. We'll find different applications. Like I don't know, and I don't think people that designed the GPS satellites all those years ago, which initially were designed for US military to guide missiles and to know where each unit is. I don't think those guys, those engineers who designed it, don't think they expected that in 2010s, there will be this kind of device called smartphone. And some people will create an app that based on your location will help you find a girlfriend.
It's unimaginable. For people 50 years ago, it would be very hard to explain to those guys how our technology works today, and probably it will be the same again in 50 years. It is really unimaginable. Another interesting question, many of the people that I read who talk about synthetic biology, they say that a future where humans are more and more, what's the right word, emerged with AI, is inevitable. It's going to happen no matter what. What's your opinion on that? Do you think such a future is inevitable?
Again, it all depends on incentives and what system is promoting those incentives. If we stay in the system that we have right now, which promotes reducing operating costs of businesses, then having humans, when you have AGI, artificial general intelligence, that is as good or even better than 90% of humanity, then what's the point of hiring humans? And then what's the point of augmenting humans with AI, since it's cheaper to just buy ChatGPT, I don't know, 29 or Gemini 15, whatever, that can run the business for you. So it all depends on the incentives that will be shaping human decisions in the future. Right now, we are both merging and also diverging at the same time. Because let's take programmers as an example. Many programmers right now are using various copilot tools that help them be more effective in writing code. That's an example of human and AI working together. And to some degree, you can see some kind of merging abilities to the point that some programmers are losing like half of their efficiency if they don't have access to Copilot. But at the same time, you can use AI to help you generate entire website. You just type what you want, how it should look like, and boom, it creates your entire website. And that's the path of divergence in which AIs are taking more and more work from humans, and leads to the path where merging humans and AI just doesn't make sense.
Yeah, it makes a lot of sense. It's in the long term, it's really mind blowing to think about all the things that can happen. So I'm looking forward to following your writings on this, on humanity redefined. And unfortunately, I think this is all the time we have for today. But it was really nice talking with you, and I hope we can meet some other time and discuss more in the future.
No problem. Thank you for giving me the space and for this conversation.
You're very welcome. Thanks for joining me. Bye.
Thank you.